Hi again, guys. So this is another problem that is interesting, and it can be solved in multiple ways. I'm gonna try to solve it first using law of sines, so you can get used to it in case you haven't. And then I'm going to solve it using force decompositions and force addition like I did before. So the first thing is, of course, read the statement, and after you read the statement, read it again and read it, slowly. Let's see what is happening here. It says two forces are applied at the end of the screw eye here. Okay. Determine the angle, this angle. This is important. So, because it's just based on geometry, so that angle, depending on how you calculate it, could be bigger than 90, but they are restricting it between 0 and 90, which is good. And the magnitude of the force F. So we don't know this angle and we don't know the force F. We have to know something else. In this type of problems in 2D, usually the maximum amount of unknowns that you can have is 2. So you can solve it, 2, no more than 2. And so far we have these and these are unknowns to us. But they say that the resultant force is acting, and this is extremely important because that's giving you the direction of the resultant force and the magnitude of the resultant force. So basically, they are telling you this: the resultant force acts here, and it's 750. Whatever magnitude we are talking about, newtons. I'm not saying magnitudes are not important, but right now I'm more concerned about finding the values, and then I will put the magnitudes. So what do we do now? Same thing that we did before. Exactly same thing. You go parallel to this line, you go parallel to that line, you go parallel to this other line, you go parallel to that other line, and you form a parallelogram right there. This side is F, this is 30 degrees. We don't know this angle. I'm going to call that alpha. We know this side, 750. We know this side is 500 because it's the same as this one. And this angle here, we don't know it, but it's named theta. So let's keep it like that. Now I can start working with this triangle that I have here. You can copy it outside if you want to. You can keep it there. It's up to you. Because I'm just solving it for you, I'm going to copy it here. So then I have 500. This angle, I don't know, but it's not 90 degrees. Don't get confused by the drawings. This is 30 degrees, and this angle here says theta. And I know this side is 750. This is the information that we have here. Okay, so now what can we do? We can apply the law of sines. Remember law of sines. Once again, I'm gonna state it one more time. This is A, this is small a, the angle. This is B, this is small b, the angle, and this is C, and this is small c, the angle. So sine of A divided by A has to be equal to sine of B divided by B has to be equal to sine of C divided by C, or vice versa. So A divided by sine of A equal to this, equal to that. Well, I guess that in this particular case, I have sufficient information because I have this side, 500, and I have this angle, and I have this side, and I can calculate this angle, alpha. So let's do that. I can say sine alpha divided by 750 has to be equal to sine of 30 divided by 500. That means that I can solve here for sine alpha, and sine alpha is going to be equal to 375 divided by 500.75, 750 times sine 30, which is 0.5 divided by 500.75. And from here, I can just take the inverse of that, Remember, in this calculator, the inverse function, you get 1 is the sine, second time is inverse sine, hyperbolic sine, inverse hyperbolic sine. So you have to keep it in inverse sine like that. 0.75, and you get 48.59. And then you have this angle. So once you know this angle, basically you can just go and solve for the other force that we are needing, which is this force. Because if I know this angle, I can calculate that angle. So if I know that angle, theta will be equal to 180 minus 48.59, because the sum of these three has to be 180, right? Minus 30, and that would be 180 minus this minus 30, and that angle will be 101.41. Now we start seeing, or at least I start seeing weird things happening, because I know you shouldn't be just paying attention to the drawing, but if you draw this scale, which is kind of drawn up to scale, and it's very easy to draw at a scale, you start to realize that this is not possible, because this angle looks like it's almost 90 degrees in this, and this is almost drawn to scale. So this is one of the things that usually mathematically is correct, but from the engineering point of view, it doesn't make sense, because it's going to give you a different solution, which is valid, but it's not the solution that we are looking for. And why is this happening? This is happening because you're letting the math use you. You're saying everything that comes out of the calculator is correct, and you don't even question the values that you are getting. So please, start from now on trying to interpret the values that you are getting from your calculators. Now what's happening here is this. I'm going to show you, I don't know if that is valid. I mean, valid is, I don't know if that is a good way of teaching it, but it should be, because I learned that a long time ago and I still remember it in that way. What I do is something like this. I do cross, and I say sine and cosine. And this is just telling me that the sine is going to be positive in these two quadrants, because it's above zero, right? And the sine is going to be negative in these two quadrants. And the cosine is going to be positive here, but it's going to be negative here, because this is positive here, this is negative here. And the cosine is going to be also positive in these quadrants, because it's in this side, but it's going to be negative, and it's positive in this quadrant, but it's going to be negative in these quadrants. So just the way they are pointing, right? So the sine is going to be positive here, and the cosine is going to be positive here, but in this quadrant, sine will be positive, cosine will be negative, and so on. What does that mean? That means that this sine of alpha of 0.75, yes, that is a valid result, and it will correspond to this angle. But it will correspond to another angle that is here as well, and it's going to yield the same value of 0.75 in that side. Meaning, this is not going to be the real value for alpha. The value that we're looking for alpha is going to be 180 minus that one. So it's going to be the other angle in the other side. Let's try what I'm telling you. So if I say that sine of alpha is 0.75 and I calculated this angle, now let me try with the supplementary angle, which is 180 minus that. So if I say the alpha is equal to 180 minus the value that I got, that's 131.41. So let me try to get the sine of 131.41. It's going to be 0.75 as well. And this is the angle that we're looking for, this one. not this one. And it makes sense because that angle here, the angle that we are looking for over there, it has to be big. It has to be big. And this angle that we calculated was really small. So be very careful with that part. Otherwise, you're getting results, but the results are going to be mathematically correct, engineering-wise wrong. So be very careful with that. This is the angle alpha. So if I know that angle alpha, now I can calculate the real theta. And the real theta was going to be, I had this, I had this, and I had this. 180 minus that one, minus 30 degrees. And that will be, you know, the dramatic pause is that I'm calculating. It's going to be 18.59, 18.59 degrees, 18.6 degrees. That's the angle. Now I can calculate my other value for f. How do I calculate my value for f? I can say, for example, f divided by sine of that is going to be equal to 500 divided by sine of 30. And from here, I just can switch. Remember, this is 18.6, and I can pass this to that side. So it's going to be the sine of 18.6 multiplied by 500 divided by sine of 30, which is 0.5. I don't know what I'm putting sine of 30, and that will be 318.96. So F will be 318.96. Now the units, Newton. That's it. If you need to calculate the direction, well, the direction is given already because if this is 30, this is 60. The direction for that one. So you don't need to do anything else. Now, what would happen? What would happen if we continue with that angle? I don't know. I never done it before, but let's see what happens. If I continue with the wrong angle, that means that this value here will be, let me see, 180 minus 48.59 minus 30. Oh my God, I'm so smart. I calculated before and I'm recalculating it. So this is the angle that I have. So if instead of putting that angle now over there, instead of this, I put that one, that would be sine of that multiplied by 500 divided by sine 30. And that will be another value for force, you see, 980. Which, as I'm telling you, mathematically, it will be correct. But what will happen in that case is that this force is not going to be directed in that way. It's going to be a rotated triangle somehow. Pay attention to that. That is a make or break of a problem, okay? Interpret your results. See you later, guys. Hope you enjoy the video. Keep watching. Trying to stop these things.